All right, so now we're going to talk about specific parent functions. Parent functions are the most basic function in a family, or basic equation in a family. And when we transform graphs, we can always use the parent function to help us figure out where the transformation is and what the shape of the graph looks like. So we've learned linear equations. Linear equations, the most basic form is y is equal to x. But we remember learning y is equal to mx plus b, where we have something maybe like y is equal to 3x plus 2, and we graph our slope and our y-intercept. Now, the most basic linear equation is y is equal to x, that has a slope of 1 and a y-intercept of 0. So on the graph, it starts at 0, 0, and the slope is up 1 and over 1, up 1 and over 1, up 1 and over 1, and it keeps going like that. So the linear parent function, the most basic graph for a linear equation, is y is equal to x squared. Now, we have not yet learned how to graph any of these others. However, we will be learning how to graph quadratic equations and absolute value equations. A quadratic equation's parent function is y is equal to x squared. An absolute value equation parent function is y is equal to the absolute value of x. And these are the general shapes of it. A quadratic graph looks like a U shape, and an absolute value looks like a V-shaped graph. And then cubic graphs. The most basic function is y is equal to x cubed, and it has this shape on the graph. A square root graph is y is equal to the square root of x, and so it has this shape. And then a cube root graph, y is equal to the cube root of x, has this shape. And so for this lesson, we do not need to know the shapes of the graphs. We will need to know the shapes of the graphs in level 4. For this lesson, what I want you to know is the equations of a graph, or of each of these functions, because that's what we will be writing and looking at down below. So for numbers 1 through 9, it says what kind of graph does each equation display, and then describe the transformation that occurred. So for number 1, since you see this squared, what that means is that this is a quadratic function. Okay? And with that quadratic function, we have a plus 3 on the inside, so that's a horizontal translation left. And then we have a plus 5 on the outside, so that is a vertical translation up. So we have a horizontal translation left 3 units, and a vertical translation up 5 units. And that is all that happened to this quadratic function. Now number 2 is also a quadratic, because we see that squared. So we're going to state that this is a quadratic function, and then we're going to describe the transformation. Since there's no parentheses, then this minus 1 is technically on the outside of our function, so that is a vertical translation down 1 unit. All right. And then number 3, we have, since you see those absolute value symbols, that means that this is an absolute value function. And there are 2 things that happened here. I have a negative on the outside of my function, so that means that that was a reflection over the x-axis. And then I have a 2 on the outside, which means that that was a vertical stretch by a factor of 2. So we're going to record both of those. There was a reflection over the x-axis, and then there was a vertical stretch by a factor of 2. All right, moving down to number 4. So with number 4, we see the square root symbol. This is a square root function. All right, now there's multiple transformations here as well. When we see the negative inside of our function, remember that is a reflection over the y-axis. And when you see that -2 on the inside of your function, that is a horizontal translation. And remember, horizontal translations are the ones that are more difficult to remember. That's a horizontal translation to the right. So we're going to state that there was a reflection over the y-axis, and then there was a horizontal translation to the right 2 units. All right, number 5. When you see this cubed symbol, that is a cubic function. And the only thing that happened here is we have this +3. There's no parentheses, so that means that that +3 is on the outside of your function. So that means that this is a vertical translation up 3 units. All right, number 4. We see those absolute values. This is an absolute value function. We see the negative on the inside of the absolute value. That means that there was a reflection over the y-axis. And a -2 or a -2 on the outside of the function. That means that there was a vertical translation down 2 units. Number 7, I see the square root, so that means that this is a square root function. I see the 1/3 on the outside, so that means that this was a vertical compression or shrink by a factor of 3. And then the +1 on the inside would mean that this is a horizontal translation to the left, whereas the -6 on the outside would mean that this is a vertical translation down. So I have a vertical compression by a factor of 3. I have a horizontal translation to the left by 1 unit. And I have a vertical translation down by 6 units. Okay, number 8. Number 8, we see that square root. It is also a square root function. This -4 is on the outside of my square root, so that means that that is a vertical translation up 4 units. And then number 9, if it's just an x to the first power here, that is a linear function. And since that -4 is not within parentheses, that means it's on the outside of your function. So that means it is a vertical translation down 4 units. Okay. So there's all of our descriptions, and now we are going to practice how to go from a description to an equation. So first, we are given what type of function we are dealing with. We are dealing with an absolute value, so that is the parent function y is equal to the absolute value of x. Now a vertical shift up 5 units would mean that 5 is on the outside, whereas the horizontal shift right 3 units means that the 3 is on the inside of your absolute values. So I would have y is equal to the absolute value of x, and a shift to the right would be a -3. And then a shift up would be a +5 on the outside. This is your correct equation that represents the transformation. Now, number 11, we have a square root function. So that is y is equal to the square root of x. I have a reflection over the y-axis. That means that your negative is going to go on the inside of your square root. And I have a vertical compression by a factor of 2. So that means with it being a compression, that means it's a shrink. And that means that your k value is going to be in between 1 and 0. So your k value is not going to be 2. It's going to be the reciprocal of 2, which is 1/2. So I have y is equal to a 1/2 and then the square root of -x, because that negative represents the reflection over the y-axis. This is your function. All right, number 12, I have a cubic graph. A cubic graph is y is equal to x cubed. So now we're going to reflect over the x-axis, which means that that negative is going to go on the outside of my function. I have a horizontal shift to the left by 4 units, so that's going to go on the inside of my function. And a vertical shift down 2 units will go on the outside. So I have y is equal to a negative, and then I draw parentheses x, and going to the left would be a +4 cubed, and then a vertical shift down would be a -2 on the outside. This is my correct function. All right, number 13, quadratic. So that is y is equal to x squared. I have a reflection over the y-axis, so that's going to go on the inside of my parentheses. I have a horizontal stretch by a factor of 3, so that's going to go on the outside of my parentheses. And I have a horizontal shift left 8 units, which goes on the inside of my parentheses. Now with this, we need to be careful. So I have a y is equal to, and the horizontal stretch, sorry, that should not say horizontal. We haven't done horizontal. Let me change this to vertical. And on your copy, it should say vertical. So a vertical stretch by a factor of 3 means that we're going to put that on the outside of our parentheses. Then the reflection over the y-axis, we have a negative on the inside. And then the horizontal shift left, we need to be careful. We're going to do another set of parentheses, and then we're going to do an x plus an 8. And we're going to close our parentheses and then square it. And that's it. This is how we write it. Be careful not to include that negative on the inside of that x plus 8. And there's a reason for it, because when we're doing a reflection over the y-axis, we want the reflection to affect both of the terms inside of that x plus 8. But if I just wrote the net minus in front of the x on the inside of the x plus 8, then that minus sign's only affecting the x and not the 8. So we want to write it like this. All right, so number 14 is also a quadratic, so we're going to do y is equal to x squared again. I have a vertical stretch by a factor of 5, so that 5 is going to be on the outside, and I have a vertical shift down 3 units, which would be on the outside as well. So there's 2 ways you can write this one. You can write y is equal to, and then a 5 times an x minus a 0 squared minus a 3, because we're not doing a horizontal shift, so my horizontal shift is 0 units. Or you can write it as y is equal to 5 times x squared, like this, minus 3. I don't care which one you do. And then the last one.